In this video, we're going to take a look at some of the fundamental methods and data structures that you can expect to use with the Pandas library. We're first going to take a look at the series data structure, and then we're going to dive into the data frame structure that is available with Pandas, and this includes selecting different rows, columns, transforming your data, and also filtering your data. If you find this video useful, please give it a thumbs up and also consider subscribing to the channel. I'm going to begin by importing pandas and numpy into my workbook using the convention of pd for pandas and np for numpy. And to begin, we're going to create a Panda series, which is a one-dimensional array of data. I'll create an array of years from 2001 to 2003, and then another array which I will call food_profit, and this will represent the profit our company have realized each year from selling food. I can now create a data series from these two arrays using the Pandas library. I will use pd.series, and within the series you need to define your data, and for us that will be the food profit and also an index, which are the years. Our index enables us to identify each unique element by row, and as our profit is representing a single year, we will use the years as an index. I can now print out our series and we can see a neat table of values with the year on the left and the food profit on the right. I can also verify the type of our series by passing it into the type method, and we can see it as a Pandas series. An alternative way of creating a series is by defining a dictionary and passing that into the series constructor. So I'll create a dictionary of years and profits for food. Then I can create a new series using this dictionary. And we can see the same result, just a slightly easier way or neater way of creating it. The index values of our series can be returned by using the keys method, so we can see the unique index we have assigned to our series. So that will be the extent of our work with Panda series for now. So let's dive into Panda DataFrames, which are the most commonly used structure with pandas. So DataFrames consist of multiple data series that are applied alongside each other. This makes DataFrames a two-dimensional data structure. Before I begin exploring DataFrames, I'll create a new series similar to our food one, but let's just say this is for drink profits. Then we'll be able to create a data frame that consists of both our food and drink profits side by side for each year. Now that we have our drink profits, I can create an array of these with the food profits using numpy. And I'm just going to transpose the array so our data is represented in columns rather than rows. If I print our profits to the console, we can see the drink profits on the left, and adjacent to this are the food profits. I can transform our profits array into a simple data frame by using the pd.dataframe constructor and then passing in the array. We can see this printed with numerical columns and index values. We can assign the index, which we would expect to be the years, and the columns of drinks and foods by recreating the data frame. When constructing a data frame, we want to pass in the data as the first argument, the index as the second, and the columns as the third. Alternatively, you can use the keyword arguments where you specify what the data is equal to, followed by the index columns. Now if I print the new data frame, we can see it's showing food and drink profits for each year. So that's the basics of creating a series and data frame with pandas. As we dive into some of the functions we can perform on the data frame, I'm going to create a new data frame using the Nike financial data from the past year. You can easily download this for free from Yahoo Finance. So I'm going to create a new data frame called Nike, and I'm going to populate it using the pandas read_CSV method, and this will automatically create a data frame from our CSV data for us. Now if I print Nike to the console, we can see 251 rows with information such as open, high, low, close, and volume traded for each day for our Nike stock. We can see the columns that we have in our data frame by running Nike.columns, and the index values we have by running Nike.index. This will show us the first value of 0, the final value of 251, and the increments of 1 being made for each index. If I run Nike.head, we can see the first 5 rows printed to us in the console, and then similarly if I run Nike.tail, we will return the last 5. And we can see the difference in their date from the head and the tails. There's also a pretty handy method that will provide some key statistical information on the numerical data within our data frame, and that's the describe method. So if I run Nike.describe, it will give us the count, the mean, standard deviation, the minimum, and also some other percentage values for each column that we have. If you just want to know overall some of the stats on your data, this can be pretty helpful. So we can see details of the high, low, min, the close, the adjusted close, and volume, as all of these are numerical columns within our data frame. So if we want to pull out just a single column from our data frame, we can do that by passing in the name of the column to squared brackets from our data frame. And I'll do this for the adjusted close. We can now see a series of numbers for just that column being returned to us, where the top 5 and bottom 5 are shown and the length of 251 is recorded. If I run a type on this, we can see that it returns a Panda Series to us, so similar to sort of that food profit that we had at the start of this video. And I can also return multiple columns by passing in an array within those squared brackets to that data frame. So I'll do this for the date, the adjusted close, and also the volume. We're now going to take a look at how we can create a new series for our data frame. We can define a new series with the squared brackets. So I'll create a new column and I'm just going to call this movement. And this will capture the difference between the high and low price for a given day. And I can define the value of movement as very simply as the high value minus the low value from our data frame. Now if I return our data frame and scroll all the way to the right, we can see our new series is added to the end. It would be nice to remove our decimal places, so I'm just going to overwrite our movement series, and then I'm going to pass in the numpy of np.round with these two values as the value, and then I'm going to have rounded to 2 decimal places. And now we can see that this has been updated within our series. Now if you would like to drop a column from your data frame, you can do so really easily with the Nike.drop method. And within here we'll be passing in the column as the first argument and the column name, and importantly specifying the index as 1 in the second argument. So the reason we do this is because we can also drop a single row using this same method, and that would indicate an axis of 0, whereas by saying that the axis is equal to 1, we're telling Panda's library that we're trying to specify a column to be dropped here and not a specific row. Now if I return our data frame, we will notice that the movement column still exists, and this is because this drop method is making a change that is not in place. So that means it's not actually going to update our data frame itself, but it's just going to return what that data frame would look like otherwise. So if we want to make that change permanent to our data frame, we just need to equate our data frame to what is returned from that drop command. So in this next section, we're going to start looking at how we can update the index for our data frame. So the index of each row can be used as a unique identifier for referencing specific rows at a time. And by default, we will be given an incrementing counter from 0, and we can see this by returning Nike.index. So what we have already is a unique index for each row, and that would be our date, because each date only occurs once within our data. So I can update our index using the set_index method. And one thing to note is that this method is also not made in place. So I'll have to equate our Nike data frame to Nike.setIndex, and within the parentheses I will specify which column I would like to set as the index, and that's very simply going to be our date. If I return Nike, we can now see the date column has been shifted into that index and is now bold, all the way on the left hand side. So we can realize the benefit of setting a meaningful index when we want to return specific rows from our data frame. If we wanted to pull a specific row, we can specify the index location as a number when we want it. And we can do that using the iloc method, passing in the number 0 within squared brackets, and this will return the first row of data to us. If I wanted to return the first 10 rows, I can pass in iloc and then 0:10, and this will return index position 0 up to and excluding index position 10. However, returning the index location number is not always convenient. Let's say we wanted it for a specific date. Well, then we'd have to look in our data frame, work out which index position our date is, and then sort of passing that into iloc. But thankfully there is an easier way, and that's using the loc method. If I wanted the rows for the 3rd of February and the 3rd of March, very simply I can just pass in an array of both of these values. So I'll use Nike.loc, which usually takes in a single index value within close brackets, but instead I'll just pass in an array. And now if I run this, we can see these 2 rows are returned back to us. So this is one of the most useful methods when operating with a custom set index on our data frame. In this section, we're going to look at how you can filter for data in our data frame without having to specify the exact rows. So let's say I want to return all rows that had a volume of greater than 5 million. I can start by evaluating each volume row to this condition. So if I obtain the volume series, then ask Python if it is greater than 5 million, we will see a series returned to us of booleans, and these evaluate to whether the volume is greater than 5 million or not. So we can use this boolean series to filter our data. I can simply pass the boolean series into our data frame to filter it directly. We can see the data frame returned to us, where all the volume values are now greater than 5 million. The filter we apply to Nike is not limited to just a single series. We can combine filters within parentheses. So I can enhance the filter to obtain all rows where open value was greater than, let's say, 120. And I can combine these by using the ampersand on the second filter. We can now see the rows returned all have an open value greater than 120. So in the last part of this video, we're going to look at how we can apply functions to our data frame to transform values, create new rows, and the different approaches we might take to this. So we've seen earlier in this video that we can create a new column based on 2 series, such as the movement column, which subtracted the low from the high price. We're now going to see how we can apply a function to a column with a little bit more complexity. So let's say we wanted to convert our rows to GBP from US dollars. I would define a new function called convert to GBP, which takes in a number, and it's going to return the number multiplied by 0.79, and this is roughly the exchange rate from US dollars to Great British pounds. I can now use this method to transform all the values of a given column, and we can do this using the apply method call. I'll first take the closed column from Nike and then call .apply, passing in the name of our function convert to GBP. As our function accepts a number and returns a number, Python will do all that heavy lifting for us, applying this function to each row of our closed series. We can now see the column returned to us when converted to GBP, and also note that this change is also not made in place, so returning our data frame will actually return the original data once again. I can create a new column called GBP close and equate that to our apply method from above. And now we can see a new column returned to our data frame on the right hand side, where everything for the closed column has just been converted to GBP. So we can see how we can apply a function to a row of a given series within our data frame. I'm going to demonstrate this one more time. Let's say we want a new column to show a description of the volume we have. I'll create a new function called volume_symbol, and that's going to accept a number, and I'm just going to call this number volume. And what it's going to do is return a string, and that string value is going to depend on what our volume is. So let's say we want to return the string of low. If the volume is less than 4 million, then we can have mid if it is between 4 million and let's say 6 million, and also high if that volume value is greater than 6 million. I can then create a new column called volume symbol that uses this volume series and applies it to the function. We can now see this new column appended to our data frame. So in this last section, we're going to look at the Lambda function, and we want to use Lambda functions to remove sort of the unnecessary code work for defining functions and then passing them into our apply method. It's just a slight streamlined way of transforming our data. So for example, let's say we wanted to double the value in our column. What we could do is define a function called double_num that accepts a number and returns 2 times that number. We can then take a row from our data frame, let's say the GBP close column, and we can apply this function to it. But that's actually quite a bit of wasted effort in defining a whole new function, especially when it's doing something so simple as just multiplying a number by 2. So we can instead use a Lambda function within the apply method to specify the data transformation we would like to apply. So the syntax for Lambda can be a little bit confusing, but let's take it slowly. So within the apply method, I will write Lambda, and that's just telling Python that we're now going to write the logic of our transformation in a single function rather than passing in a predefined function. Next, I'll pass in a variable which represents the value we are taking in from our data frame, and I'm just going to call this GBP. And then I will use a colon to symbolize the function of our Lambda expression, and that's going to be GBP multiplied by 2. So this Lambda expression represents our function to double the value. The term GBP in this case is simply a variable name, and it represents our value. I mean, if I wanted to, I could call it val or anything else. I would encourage you to have a play around here just to become a little bit more comfortable with Lambda expressions with Python. Now, if we run this line, we can see the output series where our GBP values are now doubled. So taking this a step further, we can also use Lambda expressions for multiple column values. So I'll create a new function for simply subtracting 2 values from each other. This could be a lot more complex if we wanted to, but this is just sort of for a demonstration. Then I'll create a new series for our data frame called high-low diff, and rather than passing in a single series within the data frame, we must specify the 2 columns we're passing in within an array. So I'll pass in high and low within the array. We can then call apply and passing in the variable of Nike. When we had just a single parameter, we knew exactly which column was being passed in. So for GBP close, it could only be that because that was the only series we had. But as we now have 2 columns being processed, we need to explicitly say which one is which when it is being passed into our method. So first we define an array of high and low columns. Then in our Lambda function, our variable represents both of these columns. I'm using the word variable cols to represent for our understanding. Now we want to pass these columns into the method calculate high-low diff. So I'll call that method and pass in cols, open square brackets, and then high, followed by the same but for low. This will tell our Lambda function to take in the first and second arguments as we specify from our data frame. Lastly, I will mark the apply as axis is equal to 1 to tell Python that I'm referring to columns in the Lambda expression and not index values for rows. Now if I run this and return our data frame, we can see the new column being returned. The final function I'm going to look at in this video is the vectorize function, which will allow us to simplify how we use multiple columns in a function. Because I know this last section maybe was a little bit more complicated, but there's a much easier way of doing this with vectorize. So vectorize was introduced within the NumPy package for convenience when passing in a series of inputs to a function. However, it actually offers a pretty good performance improvement on our process. We can use this function to perform the same operation upon multiple columns. So we first write np.vectorize with a z and passing in the method call within parentheses. Then as a second argument, we pass in a tuple of the values that we would like it to use in that order. So we will have Nike and then high and then the Nike low series from our data frame. And vectorize will perform the same functionality as our previous Lambda function, however it is a lot more simple to write. We can now see our new vectorize series in our data frame below. So that concludes this video on some of the fundamental methods you can use with Python pandas. Stay tuned for further videos as we look a little bit more in depth with Python and pandas, and please like and subscribe if you found this video helpful.